This is Chapter 8, Part 2. We have 1 liter of an isotonic normal saline solution that contains 900 milligrams of sodium chloride. Express the strength of this solution both as a ratio and a percentage. Okay, well, a couple things we have to notice here. When we're talking about strengths, we always use milliliters and grams. Right here we have milligrams, so we're going to need to change that. And here we have a liter, which we're going to have to change as well. Okay, now the strength is always the solute, which is the sodium chloride, over the solution, which is the water. Okay, so I have 9,000 milligrams in 1 liter. Now I need to do my conversions. For each 1 liter, there are 1,000 milliliters. Okay, so that gives me, the liters cancel out, and then I've got 9,000 over 1,000. If I divide each of these by 1,000, I've got 9 over 1. So I have 9 milligrams for each 1 milliliter. But like I said, we don't need milligrams, we need grams. So if I take 9 milligrams for 1 milliliter, and there are 1,000 milligrams in 1 gram, the milligrams cancel, and I end up with 9 over 1,000. And these are in grams, and that is in milliliters, so I have the correct units. So as a ratio, this would be 9 to 1,000. Okay. As a percentage, I get 9, I'll turn it on, 9 divided by 1,000 times 100. So this is a 0.9% solution. Okay, so example 4. All right, read the label below and verify that the 2 strengths stated on the label are equivalent. Okay, so one is 2 milligrams per milliliter, and the other says it's a 0.2% solution. Well, remember we have to be grams and milliliters, so we're going to need to do a conversion here. I have 2 milligrams for each 1 milliliter. There are 1,000 milligrams in 1 gram. So the milligrams cancel, and I get 2 over 1,000, and if you divide each of those by a 2, you get 1 over 500. So this ratio is 1 to 500. I just need to see if it's the same thing as 0.2% strength. So I divide 1 by 5. Let's clear that. 1 divided by 500. Multiply that by 100, and you get 0.2%. So yes, these are equivalent. Okay, so let's look at it 8.5. How would you prepare 500 milliliters of a 0.45% sodium chloride solution using 2.25 gram sodium chloride tablets? Okay, so we want to prepare 500 milliliters. Okay, and what I know is I have a 0.45% solution, which I can always write as 0.45 over 100. Remember, it's always per 100, so it doesn't matter that that's a decimal up there. I can write it like that if I want to. And remember, percentages, our strengths are always given in grams and milliliters. Okay, so if I want to convert 500 milliliters, I put it over 1. Then I can multiply this by 100. This is milliliters. and this is 0.45 grams. So let's multiply this across, and we will know how many grams we should be administering. So if I divide this by 100, I get a 1, divide this by 100, and I get a 5. Okay, so I am supposed to administer, I'm going to multiply 5 times 0.45, and I get 2.25 grams. So we're supposed to give a total of 2.25 grams of the solute, sodium chloride. Okay, and that happens to be exactly the size of the tablets. So I will dissolve 1 tablet in the water, and then I would have a 0.45% solution out of 500. Okay, let's do 8.6. Read the label below and how many grams of dextrose are contained in 30 milliliters of this solution. Okay, how many grams of dextrose? Well, this is 25 grams per 50 milliliters, 50% solution. We could have used either of these. Since we're asked how many grams in 30 milliliters, I'm going to use this since it already has the same measurements for us. Okay, so I'm trying to find out how many grams in 30 milliliters. I'm going to put that over 1. Now I want to cancel out the milliliters, so those are going to go in the bottom, 50 milliliters in the bottom, and 25 grams in the top. Now the milliliters cancel, as we hoped, and I could divide each of these by 10, and that will give me a 5 here and a 3 here. And I can reduce this as well if I want to. The 5 and the 25, if I divide this by 5, I get a 1, so now I only have a 1 in the bottom. Divide this by 5, and I get a 5. So multiply straight across. 3 times 5 is 15. 15 grams of dextrose is how much is contained in 30 milliliters of the solution. Okay. 8.7. How would you prepare 200 milliliters of a 1 to 10 Clorox solution? Okay, so I want 2,000 milliliters of the solution. 1 to 10 means it's 1 part Clorox to 10 parts solution. Okay, so this is 2,000 milliliters of solution. Since Clorox is a liquid, it's also going to be in milliliters. So I'm just going to keep track of whether I'm talking about the solution or the Clorox. So this is how much I want to prepare. I know that there is 1 milliliter of Clorox for 10 milliliters of the solution. Okay, milliliter solution cancels with milliliter solutions. We don't want to cancel it with the milliliters of Clorox. You can think of these as separate units. Okay, if I divide this by 10, I have a 1 in the bottom. Divide this by 10 and you have 200. So 200 times 1 is going to give me 200 milliliters of Clorox. So what we would do to prepare the solution is we would take 200 milliliters of Clorox, and then we would add water until we ended up with 2,000 milliliters total. All right, 8.8 is a very similar problem. Okay, how would you prepare 250 milliliters of that should say 1/2% Lysol solution? Okay, 1/2%, 1/2 is the same as 0.5. So 0.5 out of 100 is how we'll write the strength of that, the percent over 100. I want to prepare 250 milliliters of the solution. And again, Lysol is a liquid, so it's going to be milliliters on both sides. So I need to keep track of whether I'm talking about the solution or the Lysol. 250 milliliters, and this is the solution, over 1 times, this is 0.5 milliliters of the Lysol for each 100 milliliters of the solution. Okay, our units here cancel, milliliter solution, milliliters to solution. And if you want to just go ahead and multiply straight across without reducing, you're always welcome to do that. That will give me 250 times 0.5, which is 125. That's milliliters of Lysol over the 100 we have in the bottom still. 125 divided by 100 is 1.25 milliliters of Lysol. So what we would need to do is we would take 1.25 milliliters of the Lysol and we would add water until we ended up with 250 milliliters total.